Good morning, students. As you know, last time we completed from the chapter thermodynamics, Hess law of constant heat summation, and what are the applications of Hess law of constant heat summation. So, after completing this Hess law of constant heat summation and its applications, today we want to start another point of this chapter thermodynamics, that is spontaneous process. Spontaneous process, or it is also called as irreversible process. Irreversible process. It is also called as irreversible process. So, what is called spontaneous process, or it is also called as irreversible process? You know, in the beginning of this chapter we completed different types of processes. In that we completed reversible process and also we completed irreversible process. But here we are again going to study what is called spontaneous process. You know that, for example, sodium hydroxide NaOH aqueous plus HCl aqueous, it gives NaCl aqueous plus H2O liquid aqueous plus H2O liquid. So, in this reaction, the change in enthalpy, standard enthalpy change for this reaction is minus 57 kilojoule. You know that the chemical reaction in which heat is evolved, that is called as exothermic reaction. So, this reaction is called as spontaneous reaction. Why? Because no any external influence is required to carry out this process. In this reaction, when NaOH react with HCl, this process is called as, or this reaction is called as spontaneous process or spontaneous reaction. Why this reaction is called as spontaneous reaction? Because you know that when NaOH, aqueous NaOH react with aqueous HCl, immediately there is formation of sodium chloride aqueous plus H2O liquid. But this reaction doesn't take place in reversible manner. Means NaCl and water do not react again to form HCl and NaOH. That's why this process or this reaction is called as spontaneous process or spontaneous reaction, or it is also called as irreversible process because it doesn't take place in reverse direction. That means NaCl when react with water, it never gives NaOH and HCl, but this reaction takes place in only one step. That means this process is called as spontaneous process. You know that here we want to write the definition what is called spontaneous process or irreversible process. That is, spontaneous process have natural tendency. Spontaneous process have natural tendency to occur. It do not require external influence. So you know that all the natural processes taking place in nature, are the example of spontaneous processes. You know that first example is flow of water. Flow of water from higher level to lower level. From higher level to lower level. Lower level. This process is natural process. It is the spontaneous process. It is the irreversible process. Because you know that flow of water is always from higher level to lower level. It is never from lower level to higher level. That's why this process is called as spontaneous process. That means natural tendency to occur. It do not require any external influence. And similarly, you know that another example, ice melts spontaneously. Ice melts spontaneously. You know that second example of irreversible process or spontaneous process. You know, above 0 degree Celsius, ice melts spontaneously. And you know that another example, that is, suppose there is a hot cup of tea. Hot cup of tea. You know that when we place hot cup of tea at room temperature, what happens? After some time that hot cup of tea becomes cold, means the temperature of tea and temperature of surrounding becomes equal. So, hot cup of tea becomes cold. Why? Because it loses energy in the form of heat to the surrounding. This is also a natural process. You know that after having idea about what is called spontaneous process or what is called irreversible process, we want to know the key points of spontaneous process. Here it is important to know that just now we completed what is called spontaneous process, the process which takes place according to its own without any external influence, that is called as spontaneous process or irreversible process. First important point about spontaneous process is that it occurs of its own and doesn't require any external influence. Occurs according to its own without any external influence. That is the first important key point about spontaneous process. You know that flow of water is always from higher level to lower level. That is the natural process. That is the spontaneous process. That is also called as irreversible process, because water flow always from higher level to lower level. It doesn't occur in reversible manner. Similarly, you know that NaOH react with HCl to form NaCl plus water, but reverse process, that is reaction between NaCl and water to give NaOH and HCl never occurs. Means first important key point about spontaneous process or irreversible process is that it occurs according to its own without any external influence. And you know that This process takes place in only one direction. Only one direction. This process takes place in only one direction. It doesn't take place in the reverse direction or in opposite direction. You know that this spontaneous process may be rapid or slow. May be rapid or slow. Spontaneous process rate may be rapid or it may be slow. And you know that here, that means this process takes place at higher rate or at very lower rate. That means this process takes place either rapidly or it takes place slowly. Means it does not tell about the rate of reaction. Means rate of process doesn't matter here. It may be slow or it may be rapid. Here another important point is that this process continues till equilibrium is reached. Till equilibrium is reached or equilibrium is attained. You know that just now we studied, suppose this is the hot cup of tea. Here, suppose the temperature of this hot tea is 100 degrees Celsius and room temperature is 27 degrees Celsius. What happens? It is the natural process that hot tea becomes cold, means this loses heat to the surrounding. Up to what extent? When the temperature of this tea becomes 27 degrees Celsius. Means room temperature and temperature of the hot tea becomes equal. That means fourth important point about spontaneous or irreversible process is that this process continues till equilibrium is attained. That is another important key point about irreversible process or spontaneous process. Now, the next point we want to complete, that is, next point, energy and spontaneity. Energy and spontaneity. Energy and spontaneity. So here it is important to know that just now we written one reaction, NaOH aqueous plus HCl aqueous. It gives NaCl aqueous plus H2O liquid. You know what is the standard enthalpy change of this reaction? Standard enthalpy change of this reaction is minus 57 kilojoule. What does this minus sign indicate? This minus sign indicate that reaction is exothermic. Reaction is exothermic. Means as the value of enthalpy change for this reaction is negative, 1 mole of NaOH react with 1 mole of HCl and it releases 57 kilojoule of heat. So what we can say, what is our conclusion from this reaction? That exothermic reactions are spontaneous reactions. Exothermic reactions are spontaneous reactions. Because this reaction or this process is the example of irreversible reaction or spontaneous process, which doesn't require any external influence to carry out this reaction. When we take NaOH aqueous and HCl aqueous and when we mix these two reactants together, suddenly reaction is found to be exothermic, means it is spontaneous. But it is not always true. Why it is not true? Because you know that ice melts above 0 degrees Celsius. You know that when we take ice, you know that it is converted into liquid water. Temperature is, you know that at 0 degrees Celsius, water is in solid state, that is called ice. When we kept in the surrounding, when we kept in open solid ice in the surrounding, you know that it absorbs heat from surrounding and it get melted above 0 degrees Celsius. Above 0 degrees Celsius, it get melted above 0 degrees Celsius. Above 0 degrees Celsius. Means this reaction is exothermic? No, it is not exothermic. It is endothermic. Here this reaction is exothermic. It is spontaneous. It is irreversible. But ice melts above 0 degrees Celsius and it is converted into water. This reaction is not exothermic but it is endothermic. How we can say that only exothermic reactions are spontaneous? It is always not true, because here it is found that melting of ice above 0 degrees Celsius is an endothermic reaction. Still it is spontaneous. Now you know that NaCl solid, another example, NaCl solid, sodium chloride, physical state solid plus Aq means dissolved in water, it gives NaCl aqueous. Enthalpy change for this reaction is plus 4 kilojoule. What this value indicates? This value indicates that reaction is endothermic. Still it is spontaneous. What we want to know, first example, NaOH plus HCl gives NaCl plus water. It is exothermic reaction. It is spontaneous reaction. Means we can say that exothermic reactions are spontaneous. But it is not always true. Why? Because melting of ice and NaCl when dissolved in water, both are the examples of endothermic reactions, still they are spontaneous. So, to decide whether reaction is spontaneous or irreversible, exothermicity is not only the criteria. So what we are going to study? Energy and spontaneity. Means all exothermic reactions are spontaneous. It is true. But from this example it is found that endothermic reactions are also spontaneous. So whether reaction is exothermic or endothermic, from this we cannot decide whether reaction is spontaneous or non-spontaneous. That's why another criteria is given in the thermodynamics to decide the spontaneity of the reaction. Energy is not only the criteria to decide the spontaneity, because not only exothermic reactions are spontaneous, but endothermic reactions are also spontaneous. That's why in thermodynamics another criteria is given to decide the spontaneity of the reaction. And what is that criteria? You you know that another important criteria is given, that is entropy. Entropy denoted by letter capital S. Here you know that, for example, suppose these are the molecules of water. Water is solid state, that is ice. It is ordered state. It is ordered state. You know that in 11th standard we studied what is the most important point of difference between solid, liquid and gas. In solid, particles are closely packed, or the attraction between the molecules in solid state is very strong. That is the first important point. You know that when ice melts, it is converted into water. That means it is liquid. Means the attraction between molecules in water decreases. That means ordered state becomes here disordered state. This is called as disordered state. This is called as disordered state. Means in solid state, that is ice, the molecules are in ordered state. In liquid state, the disorder increases, means molecules are away from each other. And you know that when liquid water is converted into water vapor or H2O gaseous, what happens here? Again, when liquid water is converted into gaseous water, that disordered becomes highly disordered state. This state is called as highly disordered state. Disordered state. It is called as highly disordered state. We are going to study another thermodynamic property to decide the spontaneity of the reaction. You know, energy is not only the sufficient criteria to decide the spontaneity of the reaction. If we say that exothermic reactions are spontaneous, it is not always true, because it is found that melting of ice and dissolution of sodium chloride in water is endothermic reaction, still they are spontaneous. That's why there is need to study another property in thermodynamics, that is called as entropy. Entropy is denoted by letter capital S. For that we taken one example. You know that in solid state, the molecules of H2O are in ordered state, means attraction between molecules of water H2O in solid ice is very strong. That means their state is ordered state. You know that when ice melts, it is converted into liquid, molecular attraction decreases, molecules are far away from each other, and that's why we called it as disordered state. But when liquid water is converted into water vapor, that is H2O gaseous state, the disordered state becomes highly disordered state, means molecules are far away from each other. So here, what is entropy? Entropy is a thermodynamic property used to measure disorder or randomness. Entropy is a thermodynamic property used to measure disorder or randomness. So what is entropy? Entropy is a thermodynamic property used to measure disorder or randomness. What we can say from this example, we can say that we can say that disorder increases, entropy increases. Disorder increases, entropy increases. Disorder decreases, entropy decreases. So entropy is a thermodynamic property used to measure disorder or randomness. You know that here melting of ice and vaporization of liquid water, melting of ice and vaporization of liquid water, melting of ice and vaporization of liquid water. Here you know that solid ice is converted into liquid water means melting of ice. You know that disorder increases means delta S, change in entropy is positive. Similarly, vaporization of liquid water means liquid water is converted into gaseous state, that is water vapors. Here disorder increases, yes, disorder increases because here disordered state becomes highly disordered. In this case also delta S is positive. So here you know that we want to know some few examples whether change in entropy is positive or negative. So pay attention here. You know iodine, that is solid, we can write it is ordered state. It is the ordered state. You know that when this iodine is dissolved in water, that means plus AQ, what happens? I2, aqueous. Here ordered state becomes disordered. Ordered state becomes disordered. Imagine what will be the value of delta S, whether it is positive or negative. Surely the value of delta S is here positive, change in entropy is positive. Why? Because in solid iodine, the molecules of iodine are closely packed, that is ordered state. But when dissolved in water, the randomness of molecules increases, means entropy increases, that means change in entropy is positive. Here iodine molecules are free to move randomly. In which state? Aqueous state. They are far away from each other, that's why change in entropy is positive. You know that, for example, another example, hydrogen gas, it gives H gaseous plus H gaseous. Here the change in entropy is also positive. Why? You know that here this is the molecular state of hydrogen, H2 molecule. This is the atomic state of hydrogen, and you know that we can say that this is the ordered state, but this is the disordered state because they are separated from each other. Disorder increases. That's why the value of delta S for this process is also positive. Now I want to write some examples, and I think you can understand or you can imagine or you can give the answer of these questions. That is, in this given reaction, the delta S is positive or negative. For example, hydrogen gaseous plus oxygen gaseous, it gives H2O liquid. You know that reaction is not balanced. 2H2 plus O2, it gives 2H2O liquid. Now reaction is balanced. You know that hydrogen and oxygen, both the reactants are in gaseous state. Is it ordered state? No, it is disordered state. Ordered state. Why it is disordered state? Because you know that in gaseous state molecules are far away from each other. Intermolecular attraction between molecules in gaseous state is very less. It is very negligible. But gaseous state is converted into liquid state, means molecules are close to each other, or attraction between molecules in liquid state is more than gaseous state, means disordered state decreases and here it will becomes ordered state, less disordered. We can say that it is less disordered state. So what will be the value of, you know that when randomness increases, delta S is positive, but here randomness decreases. The molecules which are far away from each other in gaseous state, they come close to each other. That means obviously the value of delta S for this process is found to be negative. You know that. One more example. For example, calcium carbonate CaCO3. You know that it is the solid substance, salt, calcium carbonate. You know that when we heat, it gives calcium oxide solid plus CO2 gas. Can you imagine what will be the value of delta S? Yes, the value of delta S is here positive. Why it is positive? Because in calcium carbonate, this is the ordered state, but it is converted into carbon dioxide gas, disorder. Ordered state becomes disordered, means entropy increases. That means delta S is positive. Okay, in next lecture we will complete quantitative definition of entropy, and then we want to complete a second law of thermodynamics, and last point, Gibbs energy. Okay, thank you.